Assignment 3.1. So, I guess it was Friday. We talked about trophic pyramids and why they have that shape. Even though you've got a constant influx of energy from the angry sun and a constant supply of nutrients from the producers, even though the grass keeps growing, you can only support so much cricket biomass with that grass, and those crickets can only support a much smaller amount of mouse biomass, which keeps renewing itself all the time. There's always more mice, but that can only support a much smaller amount of bear biomass. Bears eat mouse. I said so. Uh-oh. No, they never brought me one.
They never bring anyone? Okay. Is there any other tape we use?
You can put a post-it on my car and I'll get some out of my, I have caution tape at my house.
Okay.
I have caution tape at my house.
His experience. And then can I put you in the locker right now?
Put it on my dashboard. Okay, and what's your face needs help on the chest?
What'd you call Brendan?
What?
What'd you call Brendan Johnson?
What?
Did you see Brendan on today?
Bro, I forgot. What was it called?
Rondon. Anything wrong? Bring ding.
Like I'm still up to like 20% student name recognition right now.
Just write on the whiteboard.
Right, bring down. Period. Whatever.
Yes?
All of you guys are saying the same thing, but like it's not right. That's like your fault.
It has happened that I miseducate them and that they all refer to
Like
something
you
as.
say the statements swim the opposite way from the wind moves the other way.
I don't think so. Ever heard of that?
You just can't swim.
Yeah, pretty sure they're good at swimming either way. Okay, so back to me. Yes, mouse eats bear, bear eats mouse. But wait. There was an actual, wait. There was an actual question here. Okay, there was an actual question here. I wanted to get to some. If I have 1,000 calories of corn, and I don't like corn, but I do really like steak. Why wouldn't I just feed my corn to my cow and then eat the cow? Isn't it the same thing, 1,000 calories?
You need 9 times more corn.
Because what do you mean I lose energy in the process? I will feed all those calories to the cow. I can guarantee you I have a very well-trained cow. She's very hungry. I'm going to make sure that she eats 1,000 calories of corn. What do you mean I'm going to lose calories? What? She'll get 9 times those calories? That's good. I eat a lot of beef.
You're going to lose 90% of it.
I will not lose anything. I swear they're in there. Look. I don't doubt you know this, but the reason that I'm dragging this out over an entire weekend, and it's been now like 65 minutes of talking about the same thing, is because I know it's on every AP test, children. I'm not saying you don't know it, I'm saying you suck at saying it. And you weren't here to see the Unit 1 exam review because you're a math class, but trust me, it's really nitty-gritty. Like, you got to say the right parts of the explanation. So this is worth your time. You need to fix your notes. Why wouldn't I just feed 1,000 calories to the cow and then eat the cow because beef is tastier? Why not?
If you lose, it's either like 10 or 90, and there's like this percent, it's lost.
Okay, so yes, there's something like that, but if my brain surgeon said, yeah, don't you have like a part in there that either you need or you don't? Trust me, I'm going for it. That's not a good brain surgeon job. But you're right, there is something about 90-10. What is that about 90-10? What is that?
90% is lost as heat and 10% is passed as energy.
In what, where? Which energy, what heat, where?
Is it because like the cow burns calories too?
The cow what?
Burns calories.
You need to feed.
So what's that got to do with the 1,000 calories I fed the cow?
Like it needs to eat more than that.
To do what?
To give you that more meat.
So what happens to the 1,000 calories that went into my cow? And if you can't explain this, you need to take notes right now. What happens to the 1,000 calories I fed to my cow?
It gets
And
cut
they
off.
poop it, and then they do all that stuff. They do
run
what
around.
we do.
They burn it. They burn it. They usually burn it.
Right. The transfer of energy content from the cow to the biomass of the beef is inefficient. Because that cow is going to use up most of the calories just doing cow stuff. You could say metabolically used, which means it takes calories to run the cow. So it can only store a small amount of those calories. A very basic and cheap rule of thumb is 1,000 calories of feed could only add about 100 calories in the best case scenario to the biomass of that cow. And that's the most crazy best case scenario. Fun fact, just a little detail for food snobs, the cow's going to put on about 40 calories of beef. Eating 1,000 calories. It's about 4% efficient when fed corn. Get it?
No.
So it's called trophic inefficiency, and it relies on the issue that the cow will metabolically consume a lot of its energy input. It won't store it all as steaks. It doesn't all go into making beef. It gets used as that beef walks around the garden or whatever. Is that a cupcake in that box? Oh, bread? You say macarons? I like macarons. You like good grades? All right. Anybody want to talk more about the cow eating corn, me eating beef thing? Yeah.
Last week you go over something like the corn could feed like 8 people, but it's like if you use it.
Yeah. That's exactly what I'm getting at. If you imagine that we have a finite number of calories, which given the size of the planet, the human's population is a pretty accurate given. Those calories exist in production form, in autotroph form, right? When we eat them higher on the food chain, there's just less available for food. if our planet has a total of 1 million calories, which is a huge underestimate, but you know what I mean, theoretically, if the planet only had 1 million, we could eat all that production ourselves, but we could only get, at best theoretical global average, 10% of that if we ate the consumers. Or 1% if we ate secondary consumers. In the ocean, we eat stuff like tuna, that's like 9 levels up. 9 levels, that's like less than 1 million of the calories we could get if we ate the sardines or the algae itself. Now, there's some stuff you can't eat, right? Like, you can't really eat the green algae, so you gotta go up a couple steps. But, like, what if we could eat krill? Like, little fine plankton? There's so many calories of that. Like, such gazillion tons of calories of that. Or if we could just let the sardines eat all of that, then we could just eat a lot. We could eat so much sardines. You could rub yourself in anchovies. Is that not a pretty picture? Me rubbed in anchovies. Higher up you get in the food chain, there's a lot less calorie in that level because it spends a lot of calories to get to that level. All the favorite fishes of the world are at the very top. Think about it. Like marlin, swordfish, they're like 7 to 9 levels up. Tuna, 7 to 9 levels up. Salmon is pretty far up. Like locally here, I fish like rockfish and lingcod. They're actually like kind of lower. Like that's a lot more, kind of sustainable-ish. Yellowtail, that's pretty sustainable-ish actually. That's not too far up. Lobster is way down there. It's like an insect. Of course, in my personal opinion, we're not managing that resource very well. All right. Hey, did anybody get lobsters on Friday night, Saturday morning? I was no. I got 3 shorts after like 4 hours, and then I got a ticket. My life sucks. You?
Oh yeah, we caught 2.
2. How many people?
It's just me and my dad.
Both of 2
We
humans?
went diving.
Where?
Some
At Hams, yeah. Yeah, it seems like the divers all got 1 or 2. But you didn't see a ton, right? Like were you guys a little bit depressed coming home with only 2? No? That was like normal? Okay. I was depressed. I was expecting, for sure, double limits on my boat. Always opening day we get limits. Then I got a ticket.
like a parking ticket.
No, like a fish and game ticket. Like I forgot to fill out my lobster tag. I would have reported 0, so it gave me 0 advantage. I was not cheating. I was not lying. I just forgot to write down my 0, and it's gonna be like $400. I gotta take a day off work to go beg like Clifford Anderson's dad to not give me a ticket for the 2nd time. If he totally hooks me up, I still gotta pay $300 to get out of there. That's a lot of bread for me. All right, sorry. I'd get that off my chest. Are we done with this trophic situation? Okay. Let's get to this bullseye, because this is actually, like, a lot of kids are like, why are we talking about this? And this is actually a really important thing. It comes up a lot. Here comes your bullseye. Watch me, watch me, watch me. Humans don't want to die a miserable death. So a little bit peripheral to that is we need healthy ecosystems for humans not to die a miserable death. Everybody knows that. And those healthy ecosystems depend on diversity, so we've got to understand a lot of stuff about diversity. And as it happens, sometimes things change in the ecosystem, and sometimes humans have to get involved. So there's like a lot of ways that humans can get involved with fixing ecosystems. And one thing we got to understand, even further out on the bullseye, is like, well, we got to understand, for one thing, how ecosystems recover from damage naturally, because we might need to fix those, because we need healthy ecosystems to maintain the diversity that keeps us all alive, so we don't die a miserable death. Right? So here goes. What happens when ecosystems break down in nature? It's called succession. And you have notes on it already. It's part of 3.1. These are your questions 5, 6, and 7. And I plan to spend the next 20-odd minutes on these like 45 words, so it's not urgent. You should not be copying. I just want to point out a few things before we get started. I want to point out, number one, that your book's definition of primary productivity sucks. Your book says to build an ecosystem where none existed before, right?
Yeah. Primary succession.
That's primary succession? Cross out that definition.
What number is it? 5.
Number 5, to build an ecosystem where none existed before, primary success. Just cross that out. That's gibberish, nonsense. I know what they meant to say, but that definition really belly flopped. Your book's usually really solid, but that word, they didn't. I don't like that. Thank you, lovely doctor.
What about secondary succession?
Here's another thing I want to show you. Your book only said primary and secondary, but secondary actually has early, middle, and late, and then there's something called tertiary as well. So it gets more complicated than your book said. And don't worry, like I said, we got 20 minutes. I'll go over it. And finally, something else I want to warn you about is heads up. Sometime in your life, you'll be misled. In my ecology class at university, my sophomore year of university, my highly esteemed professor, who's a genius and a wonderful woman and a total role model, and she taught me a ton about science, she wrote the book that had a very misleading diagram. It said primary, secondary, tertiary, like grasses, bushes, and trees, like small, medium, and large. And warning, the succession of species that recover after a disturbance is not small, medium, large. That's not the order. Be careful.
What is small, medium, and large? Small, medium, early, and
Oh, I promise I'll talk about it. You'll see. I'm getting there, I swear. So, first thing you got to know, not all disasters are the same. Sometimes species recovery is really fast. And sometimes it's really, really slow. What makes it really, really slow is if you lose your topsoil. So let's start with the warm-up. What sort of disasters would completely remove, obliterate, destroy, erase topsoil?
Natural disaster? Drought.
A nuclear bomb might.
Volcanoes?
Volcanoes might, because they get really hot, the lava melts and evaporates all the life stuff.
Drought.
Floods, hurricanes.
Flood, tornado, hurricane, wind, extreme storms, not really.
What about the drought?
The drought will lower the quality of topsoil, will maybe thin the topsoil, but I want to know what's going to, like,
Glaciers.
rocks. Yeah, glaciers do that too. You might notice that Foy is conveniently reading what I already wrote on the board right there. Welcome aboard. Welcome aboard, everybody. Y'all thought he was smart, huh? No. Glaciers are really big chunks of ice, so as they move very slowly due to gravity, they go downhill. They're like a giant bulldozer, just like pushing aside all the organic material and exposing the bedrock underneath. They move so slow that you don't even know it's doing that. Because you see the snow piling up and then you die, and then many generations later the snow's getting pretty thick, and then like 1,000 years later it's a glacier, and like 10,000 years later the glacier has moved and nobody notices because it moves so slowly. But yeah, that got rid of topsoil. Glaciers, moose, volcanoes, and mass erosion. When I say mass erosion, that's like 1 in a trillion chance that you'll get such a giant water movement all at once. Like the example that people talk about, apparently, I forget what it's called, there was once historically like a gigantic lake in here somewhere, like in the Mediterranean somewhere, and the lake like blew out.
Blue.
Yeah, there was like a ring of mountains that contained a lake, and there was like a tectonic shift, and all of a sudden it split, and the water pressure started to push rocks out of the way, and like the lake, like boom, like that much water all at once, like barreled down a hill. That much water all at once, that actually did cause the loss of topsoil entirely. But usually when you have a flood, what literally happens if you're right there, watch me, is that the water level rises, and then goes down, down, down. When it goes down, usually as the water slows, it actually settles more material from above. And up above, it just kind of thinned it out. So you just kind of like slump more stuff in the flood. It's usually not that big of a deal.
What about like tsunamis?
Yeah, like tsunamis, that's a perfect example. A big rush. And usually what you get is a whole bunch of ocean sediment up on land. Because like that tsunami is not like a big like macking, breaking wave. It's just like sea level rises and then goes down. You know what I mean? It barely has movement laterally. So, if you've lost soil, you're looking at rocks, like lava. You know, like lava cools off its rock, right? Everybody knows that? Or like glaciers come through and you got bedrock, you know, like big bedrock. You could drop seeds there all day long. Birds could take a crap and leave you seeds. Wind-blown seeds could fall on those rocks, and they're not going to sprout because it's rock is rock is rock is rock, right? So, if you've lost your soil, this thing happens called primary succession, which your book kind of gave you a bad definition. I want you to replace it with a simpler definition. If you've lost your soil, the definition I want you to have is soil building. It is not exactly building an ecosystem where none existed before. Instead, it's returning topsoil where it was temporarily removed. And I could ask you how you return topsoil, but first I want to make sure we all know what topsoil is. What's the difference between sand and topsoil? And where do they come from? You could pour nutrients into sand and it still wouldn't be topsoil. Yeah, well, what are they? What bacteria in sand? You could put bacteria in sand and you still wouldn't have topsoil. You're
Nitrogen? Smaller little plant things.
what?
Like little small plants like little
Yeah, dead stuff. That's what topsoil has. Dead stuff. Yeah, but I don't like it when you talk. Ooh, yeah!
Yeah.
Got him. Smoked.
Should I just leave now?
Look, the difference between sand and topsoil is the dead stuff. That dead stuff with the bacteria and the decomposing makes the nutrients, you're all right. But the one key issue is the organic material. The stuff that's biodegrading, the decomposing content. You all know that I just spent a week, or I didn't, but we had people spend a week fixing up our topsoil down there. Anybody ever notice that this last week? There was people fixing the topsoil down in the garden. You know what they did? They mixed in organic material into our sandy soils to make it better topsoil. You know, if you call Agromin in Oxnard and you say, yo, what's your top of the line topsoil? They go, oh, we call it the 50-50. And I said, what's 50-50? Is it half compost, half sand, stupid? I'm like, oh yeah. Because the difference between sand and topsoil is the dead stuff, the compost, the decomposing organic material. So, if I have lava came down the mountain and evaporated all my topsoil. There's a place where you can see this. Mount St. Helens in Washington. Mauna Loa on the Big Island. There's like 4 other volcanoes on the Big Island, but Mauna Loa keeps going off. What happens? The lava flows and it dries up, and when lava dries up, what do you get? Lava rock. It's really porous. How do you go from porous rock to topsoil? Yeah, organic material. Where? How?
Stuck inside of little.
What?
It's stuck inside of little crevices.
Stuck inside by from how? Where?
Rain. Erosion.
Stuff in rain?
Poop.
Poop? Who pooped out there? It's just rocks.
Birds. Sometimes.
Yeah, okay. So believe it or not, yeah.
Human.
One thing is a little bit of miscellaneous coincidental stuff. Like a bird gets hit by an airplane and falls on your rock and decomposes. That's a little bit. Or a bird flies over and takes a little tiny bird poop and it goes splat. And then that little tiny little bird poop splat is a little bit of organic material. Yes, that counts. But I'm trying to cover 20 square miles of rock. How many bird poops are we talking?
All of them. Birds.
So short of that, how else am I going to get a bunch of organic material building up over time there? In a disaster, yeah, that could happen, I guess. A little wind blow, there's...
Erosion. Yeah, hurricane.
Yeah. That doesn't sound very dependable.
When the volcano would go off again,
Somebody said it, and nobody realized that he was actually right. It is the rain.
Scott.
Well, I didn't give him a lot of credit for it, because he was just thinking rain. But there's a secret about rain that I'm guessing most of you don't know, which is why I didn't really give him credit for it.
does it break down nutrients?
How does rain bring down stuff?
It's it travels.
What?
It's it way down.
No? Are you all ready for like the most mind-blowing fact that you probably have never heard that's like a fundamental of the earth that is like so obvious and simple? Check this out. Water vapor cannot condense into rain droplets in perfectly clean air. It needs dust. They're called condensation nuclei. And by the way, that's why rain dances actually work. Because if you kick up a bunch of dust into an updraft, it carries dust into over the clouds passing over, and then rain dances actually do make rain sometimes. If you do it right.
So Barbara should do a lot of rain.
We sure could.
Let's go for mountains.
It's called seeding rain. They make like special airplanes that make super thick smoke that has particulates because you need some sort of a particle to start the rain droplet. And in our atmosphere, there's a bunch of stuff like dust, like pollen, like spores from algae and mold, like single-celled bacteria, like salt crystals from sea spray. Yeah.
So like during the Dust Bowl, that's in.
It happened to be a really it happened to be a really dry time. So it was coincidentally during a drought, so the jet stream wasn't carrying a whole lot of rain. But you're right to question why that didn't. Like, if there had been that amount of dust at the right level of the atmosphere, where there was the right amount of moisture, that would have made a hell of a storm. You can see it in the Sierras. When lightning strike makes fire in the Sierras, very common, that column of smoke will build a thunderhead and will make its own rain and put itself out. I've seen that literally hundreds of times. So check this out. There's this repeated cycle where microbes sprout in a little puddle of rain. Those little algae start to grow. I'm talking like a teeny little bubble in rock. Everybody knows that lava rock is like really porous and like little tiny micro bubbles, like loofah rock. Like you clean your heels with it. Those little tiny bubbles, imagine. Rain, and a little bit of sprout, a little bit of algae, water evaporates, and you've now collected a teeny little bit of dried up algae. Then it rains next week, and like a couple bacteria drop and they eat that little bit of algae and then they dry up and die. And watch me. If you repeat these microbial life and death cycles with rain over a very, very, very long time, and I mean thousands of years, like even 10, 15, 20,000 years, you'll eventually build up soil.
So how do Hawaiian Islands have so much soil?
They actually have pretty thin soil. Maybe something about the amount of rainfall. It's a generally productive environment because it's near the tropics, so every day has pretty dependable amounts of daylight and temperature and rainfall. So it's like highly productive. The tropics in general are highly productive. But I don't believe that Hawaii has especially high amounts of soil. You know that decomposition is what makes good soil. So the deepest soils on Earth are grasslands, like the American prairie in the middle of Russia. Hey, what's this period over? Okay, I got one little detail. Watch me. Watch me. We're going to pick up here next time. Watch. Now we've built soil, we can get into plants moving in. And coincidentally, there are disasters which leave the soil. We're going to start there next time, now that we have soil. Bye-bye, soil.